Section 2.8, we are looking at scatter plots again, but this time we want to be able to tell if we need to use a linear regression or what's called a quadratic regression. So we want to talk about how to decide which type of a model. And so for us, our decision making is going to be based by enter the data into your calculator, and I'm going to just say into, we're going to call it stat and edit, and you would enter it into L1 and L2. So you're just going to make your lists of your data, but then you need to observe the pattern. So I guess you can look at you turn stat plots on for graph 1, and I'm going to demonstrate this. But so basically, a lot of you have a calculator that's similar to this, and we've been graphing things under y equals, and some of you have been having trouble, like if you'll call me over and your graph won't graph. Usually I can go into stat plots and I turn all of your plots off. So if we're going to graph something that is statistical in nature, we're going to go down to graph 1, we're going to turn the plots on, and then this first graph is our dot plot, and so we want to tell it, make me a dot plot and get all my X data from list 1 and all my Y data from list 2. And show me what you can use dots or pluses, I don't care about that. So that is what you have to do for that. So when we say how to decide whether a set of data can be modeled by a quadratic, you want to observe the shape of the dot plot. Okay, and so this is where a knowledge of your parent functions comes in. So if you have a general line, that's going to be linear, that's going to be y equals x. But you might just have a partial parabola. But even with a partial parabola, anything that has any downward and then upward movement, I would use, that's going to follow the general form of the parent, which is y equals x squared. So that's a quadratic regression. You can even have other shapes. You could have like this is a cubic regression, and I think in your calculator it looks like that. So all of our parent functions have an associated regression with them, but this is the one we're going to be worried about today. So let's take a look at this set of data. In example 1, so let me just answer this here again. We're going to use the quadreg function, and that is in stat, and then after you have your list, it'll be in calc, and it's number 5. But you can see there's cubic and quartic, so there's lots of different regressions that you can do. Okay, so for this example, I want to go ahead and enter my data into my lists. So I'm going to hit edit, and I want to clear out whatever's in there. Let's see, I can go up to the top of the list, clear, no, that didn't work, clear list, for clear list, L2, stat, clear list, L1. Now let me enter my list. So L1, I've got -1, 0, 2, 5, 9, 12, 15. And then go back up to L2, make sure I get the right corresponding data, 8.7, 3.45, -5.55, -15.3, negative 21.3, negative 20.55, and negative 15.3. Okay, so let me go ahead and look at my plot. Turn the plots on, so window range. So I need to get my window to at least fit this data. So my lowest is there, my highest, no wait, my lowest is -1 on the x's. So I'm just going to go to -5, positive 16, here's -20, positive 10. So now I have a syntax error. How do I graph this graph? Let me pause the video and come back to you. Okay, so I kept getting an error, so what I did, I went into my y equals, and one of these graphs had something in it. You need to have the y equals graphs cleared out if you're going to use stat plots. So I went ahead and cleared everything, and so now when I go to graph, I can see that my graph has this nice parabolic shape, and it's looking like I maybe didn't set my window quite big enough. I just went down to -20, and actually I have some data below that, so let me fix that. And so now my parabolic shape is even more apparent. So when I see that my data is following a curve that's roughly in the shape of a parabola, I can do a quadratic regression. So that's in Calc number 5. And let me see, do I just press enter? Yes, look at that. So it's going to automatically pull the data from the lists that I've entered in. So, and it's going to give me an equation in the general quadratic format. And so we have A, and I'm going to round. So A is 0.25, B is -4.99, so I'm going to call that -5. C is 3.448, so I'm going to call that 3.45. And then my r squared value, that's how closely it fits this line, and it's actually super close to 1. So this data actually is almost perfectly parabolic in nature. So remember when you guys were asking me about the baseball problem and where did that formula come from? Probably one of the ways would be to take some actual measurements from a ballpark and to run those numbers through a quadratic regression, and then you can get those formulas that have all those big decimals. There's other ways, because they did give us the angle that the baseball was hit in, and we're going to be studying polar coordinates later, so there's other ways to do that, but anyway, I digress. So the equation for this model is going to be 0.25 x squared minus 5x plus 3.45. And so let's see, I think there's not much more to this chapter or this section. So let's see, if it isn't easy to tell from the scatter plot which type of model some data should be modeled by, then you should use your library of parent functions and just choose the model that fits best. So I'm going to just say use library of parent functions. And you can tell if something fits the best because it has an R value closest to 1. And that's that for section 2.8.